All right. Thank you, everybody, for coming back in after lunch. And thank you for being here. It's so nice to be back at my alma mater. And just a shout out to my alma mater. I didn't know how well I was trained until I left. So thank you. Thank you to all of the professors who made that possible. And it's so nice to be home. So we're going to talk to you today about managed grazing, one of the most complicated and important systems in the larger food system. Cattle are grazed in every ecosystem across the globe. And I think except for Antarctica, they are absolutely everywhere. And they're special. They're beautiful, as we've talked about today. Cattle are absolutely beautiful. They contribute significantly to methane emissions from grazing systems. And like a previous speaker mentioned, every cow, every steer, and every heifer out on grazing has a choice. They get to choose also what they do. And so it makes our jobs very difficult. So this panel today is going to talk to you a bit about the importance of place in research. And when we think about place in terms of grazing, we think about the ecosystem. We think about the social and cultural aspects of place. And we think about the economic considerations of place. They're also going to talk to you about the challenges of measurements. From greenhouse gas emissions to animal intake, to soil carbon sequestration, to plant diversity, to wildlife biodiversity, the things that we try, and I'm going to put emphasis on the word try, to measure in grazing systems are very challenging. And finally, they're going to talk to you about the practicality of application of mitigations and improvements in research and in the real world. So fortunately and unfortunately for many scientists, cows are owned by people. And people make decisions about managing cows, right? So the practicality of adoption is not just focused on the science of the cow, but also the science of people and those social structures. So I'm going to introduce this esteemed panel, many of whom are not just professional colleagues, but dear personal friends. And the first one is Dr. Logan Thompson, who I had the distinct honor of having as a postdoc in my lab. So to the UC Davis family, there is an extension of our academic family in Dr. Thompson. Logan grew up on a registered horn Hereford ranch in central Texas, which instilled a passion to improve the sustainability of beef production by developing practical solutions for producers. Through his teaching appointment, which he has, he aims to give students the tools necessary to speak and understand the evolving space of sustainability and to be successful as the next generation of farmers and ranchers who will serve as the stewards of the Great Plains. Logan's predominant research interest is measuring greenhouse gas emissions in grazing systems and how grazing management impacts ecosystem function. Of particular interest is how the soil-plant-animal interrelationships are manipulated by management decisions. Dr. Thompson?
Yep, thank you, Dr. Stackhouse. And for the record, I'm connected with UC Davis more ways than just her. Dr. Place was my master's advisor until she orphaned me. And Dr. Mittlohner's advisor was my undergraduate boss, Dr. John McClone at Texas Tech. So there's a whole lot of connections here. See if I can get this to move. When Kim asked to talk about managed grazing, first thing was, well, what the heck is managed grazing? It's pretty different, right, across the board. And if we're thinking of this in like an environmental lens, right, you just heard my background. I'm from Texas. That means I'm deeply suspicious of everything. Kim calls it my black helicopter syndrome, right? Deeply suspicious. And I'm very practical, right? Grew up on a ranch. I also spent a lot of time in cell barns. So you get to know a lot about people through their animals that you see come through your gates. If you've ever spent time in a cell barn, you probably understand that, right? So I try to ground myself in those production realities with our research, right? I'm not the smartest animal scientist in this room, yet alone on this stage. and pretty production relevant, right? So I want to talk about three different topics when it comes to managed grazing. The first is who is grazing. Next is what are we grazing. The third is how are we grazing, right? So starting with who is grazing, you see these three pictures up here. These are all taken at about the same time, early to mid-May, in different places across the country. So right above my head is southwestern Kansas, some heifers on some old CRP land, which is really fun and, just as you can tell, highly nutritious, right? The center is some cows, some Cinepole composites in northeastern Alabama. You can tell nutritionally, their needs are being met, right? They're in probably peak lactation around this time. If we're gonna reduce their emissions, we need to think of an additive, right? Or something else rather than just meeting their nutritional demands. Same over there, you got the Hereford. That's also extra credit on all my exams if you're ever in my class. The answer is always Hereford. That cow's also getting her nutritional demands met, right? So for those, we need to think about something else. For this girl above my head, we need to think about getting her body condition score met. Sorry, I'm highly caffeinated, right? So if I'm used to walking around, I'm a pacer by nature, so I'm highly, highly caffeinated. But this girl, if we want to reduce our emissions, we need to get her nutritional status corrected and get her back in a healthy calving window, right? That one's pretty easy. But looking at these two, my favorite thing to think about is what size is that cow, right? These in the center, the guy's name is John. Love John, great guy. 1,100 pounds is how much he told me those cows weigh. Those cows are 1,600 pounds, right? Producers don't run calves across a scale every day like I do, like other animal scientists do, right? They're not trained to that. But historically, animal scientists and economists have looked at cow size in terms of economic returns. Across many regions, smaller, more moderately framed cows improve returns to producers, right? About a year ago, I thought, hey, I did one of those. I published that data once. I wonder what the methane data looks like, because I actually had methane on those cows. Turns out we can reduce emissions by about 1 kilogram per hectare required to support that cow for every percentage increase in efficiency of that cow. So smaller, more moderately framed cows produce calves that provide more returns. They also are an easy avenue to reduce emissions. We just got to figure out a way to train producers on how to identify the size of their cows. And one of my old advisors as well, Dr. Ryan Reuter, did a really cool gamification study on that when he was with Extension. So there's an easy approach for us, in my opinion. Next, though, I want to talk about, what are we grazing? Oh, I got a little wonky here. Sorry, what are we grazing, right? Forage resources across the country are highly, highly variable. We've heard a lot, too, about additives when they're going to hit the market. So just think of these different systems up here. The most important system in the country, in my opinion, is over there on the right. That is winter wheat. Every year in the Great Plains, around 10 million head of cattle are released on winter wheat, both cow-calf and stockers. It has a very different supplementation strategy than this one right here. This is in High Moor, South Dakota. Very extensive. It can be rotationally grazed, continuous grazed, whatever. That's predominantly a protein cube in the winter, and then you'll see them again the following winter when you gather them, right? Very different than winter wheat. So when we're thinking of reducing our impact, right, we need to think about how these supplements flow into these various forage systems based on the supplements that are needed nutritionally by that animal. Winter wheat is predominantly an energy-based supplement. It's called Oklahoma Green Gold. Can't find anything about it because Oklahoma doesn't like to talk, right? But that is what is there. Will something like 3-NOP flow through that supplement in a way that's still advantageous, or do we need to think of a new method of delivery, right? That is something I think about a lot, is how do we get these things into the animals in a way that is efficacious, right? It's going to be very different. Up here with me, we were just talking about, I say La Junta, I know that's not that. It is? Okay, cool. I got something right today. Predominantly, I'm guessing a self-fed, self-supplemented type of thing, or salt-regulated intake, or lick tubs, right, are fairly common in the area. That's a very different system than winter wheat. Or up here, that's northern Michigan. That pasture has 8 calves on it, and it's a half an acre, right? And I can leave them there for a week because you can hear the grass grow. Right? Very different than up there. We can handle those animals as much as we want. So that was my second point. What are we grazing? And finally, how are we grazing? There's a long-standing discussion between ranchers, academics, myself and Justin are on different sides of the fence here, right, on rotational versus continuous grazing, the benefits of it, yada, yada. We get pretty hyper-focused in carbon in this discussion, and specifically soil carbon at times with rotational grazing. But we really need to do a better job of figuring out in different regions what type of management has the best return, right? Economically and environmentally, right? Ideally, those are the same thing, hopefully, but we need to know. And so to conclude my thoughts, we need funding as an animal scientist, right, who works with cows. We need funding because there's not a lot of funding to work with cows. We also need to encourage students to enter this space of grazing-based research. Like I said, there's not a lot of money, so most people go to feedlots. I have cattle in a feedlot right now. Don't love it, right? I'd rather be out looking at grass. It's just my own personal bias. But we need to get people with the skill sets into grazing-based systems to start to measure what's actually happening, because then we'll have a true baseline, and then we'll have a better roadmap of how to get to where we want to. So with that, Kim, I'll turn it back over to you. Thank you.
Awesome. Thank you, Logan. And I forgot to mention that Logan is an assistant professor in the Department of Animal Sciences at Kansas State University. So with that, we'll move to another...
Don't forget, it's sustainability is in my title, so I get to wear flannels to work, and all the other professors have to dress nice.
This is what I dealt with for an entire year, people. The next person I'd like to introduce is another dear friend, Dr. Justin Derner, who is the nation's leading, rangeland scientist. And he was the very first person when I started my job at Colorado State University to reach out and say, come visit me, how can I help? Since then, we have developed, between our two research groups, probably one of the most cross-disciplinary and cross-functional groups between a university and USDA-ARS. Our groups are absolutely blended. We try not to hire we don't hire anybody who has the same strengths that Justin's teams has, and he does the opposite. He is the Supervisory Research Rangeland Management Specialist at USDA-ARS Rangeland Resources and Systems Research Unit in Cheyenne, Wyoming. He graduated from Texas A&M with a PhD in rangeland ecology and management, a master's from Oklahoma State University in agronomy, and a BS from University of Nebraska. His research interests are to, 1, determine the potential of adaptive grazing management and the contributions of flexible stocking strategies to the sustainable intensification of livestock production in semi-arid rangelands, and 2, to provide land managers with information and decision tools needed to maintain profitability and environmental sustainability and reduce risk to livestock operations in a changing climate. He has won numerous awards and is globally recognized for his work in rangeland systems. Justin?
Well, thanks, Kim. It's a pleasure to be here, and I'm going to play off a little bit of what Logan started, and then really emphasize what Kim talked about in terms of place, in terms of managed grazing. In the first slide here, I really want to emphasize complexity, and Steve will talk about this much more in terms of decision-making. But the ranchers we work with really are dealing with lots of things when they look at complexity of decision-making. It's not as simple as Logan said, just putting animals out there, right, and collecting them a couple times a year, right? They're dealing with decisions in terms of genetics, running cows and calves and yearlings, how many animals, when and where, and then the economic returns are largely from a saleable product of calves. Now that's from their side, but also society, right? We and others expect out of them provision of ecosystem services, right? That could be biodiversity, it can be soil carbon sequestration, wildlife habitat, wildlife corridors. It could be stuff such as grassland birds up there, which are declining across most of the Great Plains I work in, and how do we provide a suitable habitat that's synergistic with the grazing practices we employ on those. And in the context of that, there's a lot of this decision-making that goes on in multi-generational families, right? We're dealing with humans that have decision-making that we don't control in terms of an experimental framework. So how do we do it? So we've kind of flipped the script. All of our experiments are co-produced. We bring the ranchers, we bring the groups to us, and we ask them, how can we help service you? And so the questions then emanate from this group, and then we employ a research team and working with Kim and her great group, how do we answer the questions they want resolved, right? So it's a lot of fun to actually do research in an applied manner, as Logan mentioned. I get to the next one. Logan mentioned this. They had some great pictures of ecosystems, right? And we manage and have grazing animals on all kinds of ecosystems. These are ones just from the Great Plains that we work in. Some of these systems are highly resilient to grazing, right? They've been around for many years, been grazed by herbivores throughout millennia, now grazed by cattle. And some, like the shortgrass stepper, is one of the most resilient systems in the world. Okay? There's others, though, that produce a lot of biomass. And so we're in the quandary of biomass or forage amount and forage quality and seasonal aspects of that in terms of decision making for the producers and ranchers. Some of the systems we deal with have been completely transformed from perennial grasslands to annual grasslands, right? So you take the Great Basin area, and a lot of this has been changed from that to an annual grass called cheatgrass, right? Truly transformative in terms of ecosystem structure, function, forage amount, forage seasonality, and quality. And then you've got a lot of the western part of the U.S. that has not only grasslands, but has shrublands involved in it. So how do we handle those sorts of different ecosystems in the managed grazing standpoint, and what sort of really manifestations will happen in terms of the enteric methane emissions from those? And then I'll wrap up here just in terms, again, with what a producer has to deal with and what we deal with from an experimental framework. I have some studies at our research sites that have been ongoing since 1937, right? Amazing data sets over that time, and we've been able to encompass, right, those different years in terms of droughts, wet years, deluges, et cetera, fires, wildfires. Ranchers deal with that on an ongoing basis, right? And so some of the things you'll see up here is what goes on when you have a very intrinsically variable system, right? One in which decisions have to be made on almost a per daily basis, but you're dealing with variability from last year's drought, or maybe this spring's deluge, right? And uncertainty in terms of what's happening into the future. You may have a wildfire, right, that comes in and changes the forage availability. You may have a prescribed fire where you're actually trying to increase your forage quality to try to enhance dietary intake. You also have some things up here where you're looking at, as Logan said, we don't always have grazing green grass, right? We have a lot of it in the northern Great Plains where we're grazing stored forage. It might be forage that accumulates over this grazing season. We don't graze, and we try to use it in the dormant season, or we put it up for hay and then put it back out to the animals during the winter period. We don't have data at all in terms of what's the enteric methane aspects of that. What happens in eastern Wyoming when the wind's blowing about 60 miles an hour, just an average blowing day, and it's 15 below and the wind chill's 45 below? That's a huge maintenance energy requirement for those animals. What's going on? And so there's really some research gaps that we're trying to fill with this and trying to deal with this sort of a grassland is not a grassland, and we can't put everything in the same box.
Perfect. Thank you, Justin. So it's my pleasure to then move to our next panelist, who I have no embarrassing personal stories to share. But Matt Wilson is a native of Indiana and earned his BS degree in animal science from Purdue in 1994. He accepted a graduate assistantship at Iowa State University under the mentorship of Dr. Ford, where he earned a master's in animal science in 96, and then a PhD degree in 1999. In 2002, he accepted a position of assistant professor in the Division of Animal and Veterinary Sciences at West Virginia University. He was promoted to full professor in 2013, and in recent years has served as the director of West Virginia University's Alliance for Regenerative Livestock, developing predictive algorithms to determine feed and water intake using machine learning, studying feed and water use efficiency, and the impact of grazing on soil health and on farm renewable energy production. He also is involved in work to train service dogs for U.S. military veterans in need and helps train U.S. Army Special Forces medics in animal agriculture. Thanks for being here.
Thank you, Kim, and thank you particularly to Joe Proudman for initially inviting me to participate in this based on a conversation we had at the National Cattlemen's Beef Association meeting. A couple things I'd like to point out here before I start. The Alliance for Regenerative Livestock is simply the name I have for my research lab. The Alliance word is very intentional. You can see the list of collaborators that I've named. There are other people that work on this work with me, and so the conversations yesterday about having conversations and working with others is very, very, very important. Some of those are colleagues at West Virginia University. Some of them are colleagues at other institutions. Some of them are in private industry, including the solar industry. I've got a team that we've recently gotten awarded the opportunity to negotiate for a DOE award to do agrivoltaics and grazing. The other thing I'd point out is I've got the symbol for the West Virginia Department of Agriculture on here. Some of that collaboration is with that state agency, and I think it's noteworthy that this summit and the activities that are happening here in California are, it seems like, often joint between the UC system and the California Department of Food and Agriculture. At my table earlier, I met someone from the Colorado Department of Agriculture. I think having those people engaged in conversations and instead of silos, I think is very important. The other thing I would tell you is, as Kim mentioned, I was trained by Dr. Stephen Ford. If anybody knows him, he's a reproductive physiologist. So my PhD was in reproductive physiology, and I got sort of assigned to work on this kind of work about 4 years ago. And I didn't know how to do it or what I was going to do, which has detriments but a lot of benefits. One of the detriments is that I think that if I figured it out, federal funders should believe I could figure it out. That is a struggle sometimes. I'm pointing it at the back. Okay, so I like to show this slide as an example, and I show this not just to scientific audiences, but as an example. On my way here, I had a 7-hour delay in Chicago Midway Airport, and so I talked to an older couple that was sitting at the table across from us. They asked us what we were doing, where we were going. So I put this slide up there. We have a centralized performance test where we collect a lot of the data I'm going to talk about, and so we have animals consigned by producers in West Virginia and the surrounding states. And we had a pair of bulls that were consigned to our winter test a year and a half ago. They were half-sibling brothers. They were born to 3-year-old half-sibling cows. They were born a day apart and weaned in the same contemporary group. And they both gained 4.2 pounds per day while they were on test. So, to my training in animal genetics at Purdue as an undergraduate, those animals should be pretty similar. This image is, we took the feed truck and filled it with the feed consumed by each of those animals and opened the door about halfway and drove out through a field. That top line of feed represents about 2,300 kilograms of feed, and that's what was consumed by one of those bulls in that 77 days. The second line, and at the end of that second line, you can see there's a little John Deere Gator parked there to give it some frame of reference. That animal consumed about 1,600 kilograms of feed during that same 77 days. That difference of just under 700 kilograms in that 77 days is significant. There was no additional performance. It was just an extra bill. And since we measure individual feed intake, we charge our consigners for what their animals eat, which caused, when we first did that, it caused sea change in what people brought to the test. But that producer got to pay a lot more for one of those animals than he did the other, for no additional performance. Okay? If we then annualize that, which is a way, and it's an academic way to take a small number and make it a bigger number by getting an average daily amount and multiplying it by 365, and you can see that difference was about 3,200 kilograms of feed. If those animals were eating the same, and there are caveats in there, but if those animals were eating the same stuff over that entire year and that difference persisted, it would be 3,200 kilograms per year. If that was 2 cows that were just in the herd, and granted they were bulls, they weren't cows, and they may not be eating the same thing, but that difference on a 10-year basis would be 3,200 kilograms of additional feed for no additional output, right? Just extra groceries. I've got 2 teenage boys, and they go through extra groceries, and that bull did too. And since we're here to talk about methane mitigation, I've taken the liberty of saying, okay, well, there is a book value, and all the talks leading up to this have said, we need to know about the individual variation because they're not all just book value. But if we apply a book value to that, it's about 750 kilograms of additional methane for no additional protein on the plate. All right. That I use this slide with all kinds of groups, particularly groups that aren't science-based, to try and put in context the value of understanding what animals do. So I mentioned that we were a centralized performance test. We were the second place in the country to install a GrowSafe system. We were the first central performance test. So in 2003, we installed one of those systems that feed bunks are on, load cells, so we know what the feed bunk weighs, feed bunk and the feed that's in it. And the animals are restricted so that only one animal can eat at a time. And so and they've got an RFID tag in their ear, so we know what every animal eats each day. In 2019, which is when I started doing this work, we upgraded that system and we installed their in-pen weighing system that GrowSafe has. So the animal comes to an attractant and they step up in that stanchion, and when they do that, we get a front end weight on them from which we can determine a whole body weight. The attractant we use to get them there is water. And when we installed that system, we convinced Vitelli, which is what GrowSafe has become, to build a meter to meter the water going in. So every day we get feed intake, body weight, and water intake. And we've started using that data, which is, it's a large data set. And we've talked the 2 days about lots of data and phenotypes, but we get a fair amount of data from that. And so we've started building predictive algorithms from that. We've got about 2,200 animal records, which if you count all the days there, it's about 150,000 animal days of records. We've gotten some records from other places talking about collaboration. There's an outfit that has a similar system in Kansas called High Plains. There's a installation of a competitive technology at University of Georgia, and we've gotten some data from them, so we're adding to that. But you can see here on the right-hand side what the book value for a predicted dry matter intake is. So the nutrient requirements of beef cattle have equations for predicting intake. And the most notable thing you can see here is that spread of data points is fairly vertical. And so the book equations do okay on average. They don't get the extremes, which are probably the most interesting animals from a selection standpoint. And our approach, and this is about version 3 of our approach, and we're trying to continue to improve the algorithm, but we do a much better job of predicting individual animals' intake. That diagonal line is the one-to-one relationship between predicted and measured. Our real goal, though, is to do this for grazing animals, and so we've got a grazing complex at WVU, and in the upper right-hand corner there, we've got the very small plots that are the traditional agronomic approach to measuring intakes of grazing animals. It's very laborious work. I'm glad I was not trained to do this because I never would have headed down this path if I had known how much work was involved there. Nate Blake in the back of the room is the graduate student that's actually done a lot of that work, and going out and collecting forage heights, hand clipping samples to build regressions of forage abundance, and bolusing animals with inert markers twice a day and collecting fecal samples, and then going all through the laboratory process to do that, to get ground truth data on what animals individually eat is expensive and time consuming, and it can't happen at scale. We've heard that a couple times, especially this morning, that if this is going to apply, right, Mr. Sturgis said, if this is going to apply, we got to get it on farm now, right, and that doesn't go on farm now. But the value, or one of the values of our system, is when animals aren't in that complex, they graze these paddocks that surround it, but they still come back to that same central location to get water. And so we get weights and water intake on them through the entire grazing season. This is what the prediction comparison is between our approach, which is on the y-axis, and the book prediction on the x-axis. And you can see that, like the barn data, the book prediction does okay on average, does a good job on average for predicting intake, but it doesn't get the extremes. And that's probably where most of the juice is, if we're going to get squeezed to juice. All right. Now, one of the questions I get is, well, how do you know what they actually ate? Because they're out grazing. Well, we don't know, but I know better than the best thing we've got is the book. right? And when I was out in Colorado not long ago, we talked to Justin, and he's using a calculation that's similar, and it's the best thing we've got, and I understand that. But there's potential in a big data world to do better in the development of tools to empower this grazing research and let people like Logan that want to do grazing research across the country and its impacts on biodiversity and other things to happen. And so if we just look at those data points that were those ones that we hand collected all that data from, which is a small subset of the total, you can see here, this is the book prediction for all those animals' daily intakes for the 2 years of data we've got. Over here on the left-hand side, we've got those same animals, their measured dry matter intake and our prediction. Today, our prediction doesn't have any of the grazing data in it yet. I actually got this data on Sunday and submitted my slides late because I was waiting on this data from the graduate students. So this stuff's happening fast. Our biggest limitation is funding to make it move faster. And our goal is to get out and do it at scale on farm. And so the units here are a couple of prototype units that Vitelli has constructed. The two on the right-hand side I've got deployed at Purdue University right now, where we're collecting data on potential replacement females that are a part of a different research project they're doing, but we're getting individual grazing dry matter intakes on those animals, and at the end we'll at least be able to rank their efficiency so that they can use that in selection decisions. And on the left-hand side here, my latest graduate student that's just joined the group, we're going to do the same kind of thing in West Virginia. And the key here is we will have a group of females that we will get grazing intakes on. We'll be able to rank their efficiencies, and we will then be able to put them in a barn and calculate their barn efficiencies. We've got a group of purebred heifers that we've already got the barn efficiencies on. They will follow those crossbred heifers, and we'll start generating that data set that has been mentioned a couple times, is what is the relationship of a controlled, confined environment or in the barn environment measure of performance and the measure of a similar measure of performance out on pasture. And the limitation here, as I mentioned before, is trying to get the funding to do this stuff because there's not a lot of money in grazing work, as Logan has pointed out. And if people don't believe that it's possible to do something using data and pushing the envelope in directions we haven't pushed it in before, it's hard to make that convincing argument to get that funding. And the last thing I would say is it's not just us. There are other technologies out there that are using big data. This is an example of a tool that a relatively recent startup called Enriched Ag is using. They're using machine vision and satellite data to try and measure forage abundance and help producers better manage their grazing. And I think that it's these kinds of big data approaches that will help us get there at scale. And I think that's a critical part of this, is it has to work on farm at scale.
Wonderful, thank you. And it will be so exciting when we can look at intake data in grazing animals and then compare it to intake and selection data in confinement and see how different they really are. So that's very exciting work. So ranchers provide such an essential and clear service to all of us in the food and other products that their cattle produce. But in addition, they manage micro ecosystems, and they do so and have done so for generations. And I'm so proud to introduce one of my favorite people, but one of the ranchers that I respect the most. Steve and Joy Wooten have the most beautiful ranch I have ever visited, and you are going to hear his story and see the pictures of that ranch today. And I'm not going to tell the full life story, but he did tell me to keep this short, and I'm actually not going to do that because as I have learned, as my research has grown in the grazing space, the importance of these stories for all of us to understand so that we can do work that is applicable and is socially and culturally relevant for the individual who is on the landscape. Steve and Joy are more involved than any ranchers I have ever met. And I want you to take a moment and think about this beautiful little place in Colorado called Kim. I love the name. And it is not bigger than a dot on the map. It's tiny. And I want you to sit here and listen to everything that Steve is involved in. He is an Associate of Science from Lamar Community College. He's the president of Beatty Canyon Ranch, the president of Purgatory Wildlife Ranch, the secretary of Chihuahua, probably messed that up, Steve, sorry, Cattle Company. He's served on the National Little Britches Rodeo Association Board, the Colorado State High School Rodeo Association Board. He's been the vice president of the Pinyon Canyon Expansion Opposition Coalition. He is the co-chair of the Biological Natural Resource Inventory Committee and the co-chair of the Historical, Archaeological, and Cultural Committee. Since 2006, he has served on the Colorado Cattlemen's Association Board. He is currently the immediate past president of the Colorado Cattlemen's Association and has served on the board of the Colorado Cattlemen's Agriculture Land Trust Board. He has served on the U.S. Roundtable for Sustainable Beef Board and is a past president. That's not even on here. He is a member of CSU's AgNext Industry Innovation Working Group. And in 2023, he was appointed to the Colorado Brand Commission Board of Directors. What would his little community, what would the beef community do without Steve? I'm not sure. The Beatty Canyon Ranch is the recipient, and I haven't actually counted these awards, but someone should count them while I read, is the recipient of the George E. Cranmer Award from Colorado Open Lands, the recipient of the Ag Journal La Junta Chamber Agriculture Award, the recipient of the Stewart P. Dodge Lifetime Achievement Award from the Palmer Lamb Trust, the recipient of Sand County Foundation, the recipient of the Leopold Conservation Award. The ranch has won the Nature Conservancy Colorado Phil James Conservation Award, NCBA's, National Cattlemen Beef Association's Region 5 Environmental Stewardship Award, and the National Cattlemen's Beef Association National Environmental Stewardship Award. Steve himself was the recipient of the Denver Business Journal Trailblazer Award. So with that, it is my distinct pleasure to introduce Steve Wooten, and I am excited for you to hear his ranch story.
Thank you, Kim. It is true. We have been very blessed. And I joke that if I'm going to spend my life on the backside of a cow, whether at a chute or by horseback, at least God blessed us with a beautiful place to do that with. In southeast Colorado, most people think about it being an open plains area of the shortgrass prairie ecosystem, but there's this incredible, diverse canyon land that bisects through the southeast part of the state. And we are a cow-calf operation, Red Angus based. We have currently fourth, fifth, and sixth generation on the ranch, Joy and I, of course. And then our younger daughter and son-in-law and their 3 grandchildren are there with us. Our older daughter and her husband are on his family's ranch in southeast New Mexico, and that ranch is also a centennial ranch in New Mexico. So proud to be a part of the industry in many different ways. There we go. So we've talked a lot about what's coming down the road, and we need to get approvals. We need to get proof of concept. We need to get more research. But there are things that we can do right now, and I look at things in the form of a balance sheet. There's always a plus side and a minus side. There's the liability side, and we'll call that the methane part of it and the carbon part of it. And then there's the asset side, and that's this incredible creature that God made that lets us do so many different things in so many different ecosystems all over the world. And from the United States, out of the USDA-ARS survey of 2017, only 85% of our cow herd brings a calf to weaning. Is there a corporation, a company, a business anywhere that would year over year over year say, I'll accept 15% inefficiency in my business? Yet we do. But what can we do immediately right now to start something while we're getting these other things figured out, how we're going to deliver to large landscapes and things like that? let's reduce that inefficiency. If we could move at 5% and be consistent at 90% of those cows bring in a calf to weaning, we've made progress. Progress that we can talk to and sell that we are getting better. We're justifying what that animal was created to do. I chose this is a first calf heifer. Her calf hit the ground. He's not even 5 minutes old. He probably weighs 67 pounds. If he's a typical steer calf in our operation on first calf heifers, at 210, 220 days, he's going to be, given the forage quality that he goes through with his life, he's going to be 530 to 550 pounds. Our mature cows are 575 to 600. That's an acceptable, and I think it's a very efficient birth to weaning growth period. We don't have any dystocia in our herd. We do an extensive amount of genetic work with our purebred breeders to make sure that we have multiple generations of no dystocia in the cow herds that we select our sires from. So I have a hard time with our industry that assists mature cows, 1,400-pound cows, that have to have a calf pulled out of them, or worse yet, you go through everything to get her to calving. She hits dystocia. She dies, the calf dies, she lives, the calf dies, but if she lives, she doesn't breed back. This is the new technology. This is the new product that our purebred breeds have brought to us. Troy talked about it earlier in the Angus breed. There's no reason why we can't have high performance and eliminate the inefficiencies of dystocia in our herd. At the other end of it, this is something that we feel is an essential part. Number one, we have grandchildren in the herd with us all the time. Whatever we're doing, they're involved in it. They're horseback, they're helping us with everything. But on the economic side of it, you talk to the folks in the packing business and the processing business, and it's bruising. Gentle cattle become a very big asset to who has them after those steers leave our ranch. They can handle them. They don't bounce off fences, they don't tear up things, and especially in that last transportation from the feedlot to the plant, you don't have bruising because of their activity. So it's a major part of our operation to maintain gentle cattle. So within our operation, we have some key performance indicators, and I'm not going to take credit for building these. Some of this stuff that I'm doing and that we've incorporated started with Alan Savory in 1979 at Colorado State University, and with Bert Tiekert and Dallas Mount and others have been those mentors that have got us here. But we made the decision that we're going to set some standards and work to achieve them. So 97% of our females need to be bred this October. Then of that set of cows that goes through the winter and calves in 2025, we expect 95% of those cows to bring a calf to branding, to spring this time of year. And there is no grace. You don't bring a calf to branding, you leave. We will not, and we sell them as terminal cows. We deliberately put on the sales sheet if we go to Laana that these cows are infertile. Why would somebody else buy our problem cows and expect a different response? We all know what that is termed as when you keep doing the same thing over and over and expect a different response. And then 99% of the calves at this time of year make it to weaning. This one drives me nuts. I wish it was a 100, but I have to give nature her 1% for lightning, for other things, but I really struggle that we pumped so much nutrition and prepared these calves so much to get the next part of their growth stage done, but yet we still have to suffer 1% death loss. And we track weaning weights, we track yearling weights, but that's not our goal. Our goal is profitability. And so if this year, the way we're starting out with a change from La Nina or to La Nina from El Nino, it looks like we're going to be dry. So let's say we're not going to hit that 575 pound factor, we're going to be at 535. We'll figure out how to be profitable at 535. We will not feed to get to 575 or 600. We just don't do that. We're blessed with being able to take the resources that are underneath the cow and the power package that we put into these cows, and we can find a way to be profitable no matter what the weight is at the time of delivery. We've incorporated a lot of technologies. You referenced Billy Cook and Enrich Ag. We're using their program, their camera to collect data over a large area. But this year we started a program that I've been working with John Abizade at Vance for several years. And thinking about it, I went through a process of trying to find a grant so that we could afford to do this. And we reached a point where I said, we either got to get off the pot or go. So we bought into it and we paid for it ourselves. So we now have 300 head of cows on 25,000 acres that we're operating. And this will be the first full growing season with Vince. Last fall, we put them in there, trained them, kind of learned ourselves how to do it in a large scale. But this year we're going to come back and we're going to start pushing on it a little bit. And this ranch has 3,000, 5,000, 7,000 acre size pastures. And what we've seen in the last 7 years on it, our cows are just like me. They like prime rib and ice cream, and they don't like broccoli and asparagus. Well, we got a lot of areas that got broccoli and asparagus on it, and I need them to go there. And I'll explain more later, but rest period is what drives us in a grazing system, not how many days I'm going to be there. So with this technology, I can build polygons and I can hold them on those shale barren areas where it's a needle thread grass, it's a harder grass to get any use of out of the first 2 weeks it's alive. And we can put them there and we can move them periodically and get a more uniform graze throughout the entire operation. So we're really excited about it. We're learning a lot about it, and the future of this technology is a huge upward growth. This example of the tower. Yep. One more slide, Doctor, and I will. 2 reasons for this slide. That's the tower that communicates with the cows, but it requires a cell service. But behind that tower is cholla cactus. And I was blessed at CSU with my senior nutrition to work with Dr. Matsushima on a study on the value of cholla cactus in a feedlot system. And being real quick about it, it is highly nutritious. It's 80% water, and by the time you get it to a dry matter basis and try to deliver it at scale to feedlots, we wiped out the entire cholla cactus in the Southwest. So, but our cows make use of cholla cactus year round, spines and all. And I've done a whole lot of preg checking, and you can tell the difference when they are looking aggressively and have a higher level of satiation rate based on whatever else is happening in that system by palpation in your arm. It will chew you up as those spines come back out. So this is an example of one of the cows that has the collar on it, and it is powered by a battery. It doesn't have a solar system on it, and you can add different levels of data collection to it that you want to, but for us in this first trial, it's just simply get it on them and learn how to use this system. It alerts them with a tone first, then a minor vibration, and if they're still avoiding that, it will shock them, and it's a powerful shock. It knocks them back pretty good. This is us putting them on this last fall. The other technology that we've been using, and the Agent Source RFID, we've been using for close to 14 years. It started with the Red Angus Association and then IMI Global, and they were wanting us to put 2 USDA tags in. We said, we can't do that, guys. Why don't you guys talk together and let's do it? And they did. So Red Angus and IMI Global use one tag, gives us our Agent Source, our all natural, our non-hormone, and this year we're applying for non-GMO with the program. We're also doing genomics. We started DNA testing all of our females coming into our herd. We're about 2/3 tested on the herd, but the key thing that I think is really cool, Brady tested all the bulls, and it's Brady and Aaron that does all the genetic selection and the herd management in our operation. Joy and I are now just cheap labor. But he got the data back from Red Angus, and our bull battery, 35 bulls, rank in the top 7% of the Red Angus breed. But what we don't know until we started with the females is, where are we? How do we know? And with this technology out ahead of us and the breeders using it, were we really getting done with maternal traits, efficiency traits, growth traits that we thought we were? And how can we dial in the ones that we really want to focus on in our herds? So this is really exciting work that we're doing, and the upside of it, I think, I've said it before, I would love to clone a set of calves, this may be the technology that lets us tighten up that uniformity. Bert Tiekert is often saying, and so does Tom Brink with Red Angus, the fastest way to get profitable is eliminate the bottom 10%. And we heard that earlier today too. The bottom 10%, just take it out and bring back some super high performance females and keep working at that. This one may help us do that without the culling. We work with Neogen on this because they also work with Red Angus, and so that information flows seamlessly between the two of them, but there are other companies, and this is an example that this is Brady's job. They are the ones that have to make the decision, communicate with our purebred breeders, learn about it, and go forward. This is an old one, but an essential one today. Heterosis is such a cheap way to do improvement. It gives you so many factors of improvement, and it's old, but it still works. So with the grazing system, we made our own grazing system. Then we started working with AgriWeb, and just this year, working with the 3M project. We're also doing, man, my brain just went dead, PastureMap. And that's because their system wants to use PastureMap. So we're using AgriWeb in our home system, but I'm also duplicating that and in PastureMap so that they can have a look in on the operation. This is an example of the pastures in our home ranch. You can see where we've got the cattle placed. It allows you a lot of stuff that maybe doesn't, you see it yourself, but when you share with leasees, when you share with federal permits and things like that, this becomes a valuable tool to justify what you're doing. This is a spreadsheet that I built years ago. Kim and I first looked at it when we were doing a grazing management project with NCBA. But the key takeaway here in 2023 is the white area, especially from March to October. We've been able to expand our grazing season to where we're grazing green grass in March and in October. So it's the amount of rest that we're utilizing in that grazing season and how much those pastures rest. Now, no 2 years, it looks exactly the same, and we do that deliberately. We want to try to be as inconsistent in a positive way. We still do line transects. I think the Enrich Ag tool is going to eliminate line transects because we also gather all that data when we move cows by horseback. We really get a deep look at the pasture before and after. But this has been a good tool for situations where we need to justify what we're doing. So we take 4 pictures, north, south, east, and west. We take a picture of that meter square. I used to clip until I got to the point where I could estimate dry matter basis and not have to do the clipping. It cut the time on monitoring really quick. So I said earlier that rest is our key. I get asked a lot, well, how do you know how many days you're going to go in that pasture? And there's lots of mathematical formulas. You can get them off NRCS, you can get them off of all kinds of places. But the simple one is, whatever your stocking rate is, divide it by 365. That's what she needs. She needs 4 acres a day. Start there. At least you're doing something to get started in an estimate. But for us, it's the rest period. Not so much how long we're in there, because we're watching what our regrowth is out ahead of us. And if we have to stay longer because we're growing slower out ahead of us, that's all right. We'll adjust it in 25 and 26. But we really focus on rest. The other thing that we work on is invasive species. Tamarisk has been one that we've taken out of our riparian zones. Another example of a riparian zone where tamarisk was removed. And if you're not familiar with tamarisk, it's an ornamental that was brought in. But in the riparian zones, it changes the pH of the water because the leaves fall off, they get leached into the water, and you raise the alkalinity of the water. So it's not so much a water thief as it is a pollutant. And when we're talking about clean water as an overall part of the beef industry, this one's important. Throughout many areas, Oklahoma, Kansas, Texas, woody trees are an invasive species. And we've seen these pastures are 30–50% covered. Our carrying capacity is reduced by even more than that because they're stealing water outside of their leaf zone. So we try to clear juniper out. We push it and we burn it. And then this is an example of this particular pasture is about 1,700 acres that we've cleared. And we're at 4,000 acres. And we've got 27,000 acres that we're trying to manage. But it was amazing to us. And it's one of those situations where I did not collect any observable data when we started this project, but post, it more than doubled what the traditional carrying capacity of that pasture was. And I'd been in that pasture since 1979, but it more than doubled it when we took out that invasive. And it was water retention that did it. So for us, I said we're holistic, but the key elements aren't always those big elk, deer, bighorn sheep, bears. A lot of the key indicators of how well you're doing are the lesser species that sometimes are overlooked. And insects are one of them that's really critical to telling you how things are going. They have to have a pretty balanced system to survive. And the birds were mentioned earlier, they're also very important to us. Key species, we're in a migratory area, but what is the abundance and the replicability? During the area that they were using cyanide pulls and 1080 pulls for predator control, we didn't see several different species of birds because they're also carrion. And when they fed on those with that long life and those chemicals, it wiped them out. We see those returning now. We got a chance to work with the Venomous Snake Society last summer, and these are two species that are a state-ranked species and also globally ranked. And to the Colorado Natural Heritage Program, we entered them into the inventory in southeast Colorado. So this is where my family is thinking about a straitjacket and a nursing home. I take pictures of cow poop, but I learned online how to judge the total digestive nutrient load in your pastures by looking at your cow poop. And I'm also looking at the insects. And this picture is to show the beetles more than anything else. But I stir it, I kick it, I turn it over, and I'm looking to see what the health is. And you can see around it, that ground is cracked. We're in a drought. And the poop is brown. It's semi-dense, so we're at about 30%, maybe a little better at total digestive nutrient, but we still have a healthy system working in our pasture. About every other year, we try to do something within the community. We talked about how we're going to get this uptake in 700,000 producers in the United States on grazing and cattle. Well, it starts at the farm gate. We were talking about it at lunch that one of the biggest advocacies is neighbor to neighbor. So we try to host something, and this last summer we worked with Dr. Tim Steffens with Texas A&M to do our grazing management school. And this picture also includes Kim's family in it, and it's one of my proud pictures. Wait, where'd it go? Anyway, it includes Kim's family, but that's what we're working for. That group of young stewards, and future business leaders and future members of the industry, that's who we're working for. Thank you.
All right, so we have just 5 minutes left, and so we want to open it up for any questions that the audience has for the panel. Clearly an esteemed panel before you. Yeah, Hayden.
Thank you. Yeah, fabulous. I was looking forward to the grazing one. I think I may be correct that this was the first panel where weaning rate was mentioned. And I've been wanting to ask a question of the beef panelists earlier about weaning rates. And I just wondered to the panelists, I think, Steve, you said 85% US national average. I'm just curious, what has been the trend in weaning rates over sort of recent decades nationally? Can any of you speak to the regional differences by sort of climate system type, and where you've seen dramatic improvements, what have been the main interventions to achieve those improvements? And can you speak to the distribution sort of beyond the average, like how good are the good ones and how long's the tail?
I'm not seeing, I didn't look further back in the USDA data, but that would be where we would get that out of is their every 10-year survey. Anecdotally, it's gotten better. I see fewer year-round breeding operations where they leave the bulls in year-round and you've got calving happening year round, and you're only selling 10 calves at a time, and that. So the industry information has probably moved that better because, like I said, look over the fence. There's more grass on that ranch. They're making more money at weaning time. They've tightened up their management. So I think within the industry and neighbor to neighbor, it's better. As you move into the desert regions and the challenge that they have with the acreages that they're running on in the Great Basin and that, it's probably part of the area that's lower. The other one that we've seen, and I visited in that part of the country, and it was referred to earlier, it's the under 100 or even under 40 head operations that there's a career that's paying the bills, and he said the cattle or the lawnmower. There are probably some that they don't mind that they just keep turning over a cow, that it's not a real cash flow basis. It's not totally, and they may not even be enterprising what they're doing. It's more of a hobby type operation, and they don't need those efficiencies or don't think they do until we get to this conversation that we've had for 2 days.
Any other questions? If there aren't any, I will go to our planned questions. Yeah, in the back there.
There's been a lot of talk about EPDs for cow-calf and so forth. What about the EPDs for carcass quality? And how do those relate with the ones that you're looking for to make the cow-calf guy more profitable?
I thought I talked enough, Kim. No, there's a tremendous amount of EPD and DNA information on that part of your development. It was mentioned earlier that it's dangerous to be single site selecting, and you can push so much performance into these cattle today that if you don't seek your replacement females outside of your herd, you'll run your maternal program right into the ground. But we can turn the crank with genetics and EPDs and genomics and do some pretty powerful things. But we had a discussion about it earlier today that we can go so far that 1,500 pound steers is what we're doing, and we're getting too big, and they've got to be trimmed. They don't fit the box and things like that. So you've got to figure out how much you need, what your environment can take in that genetic selection, and then what's the end result? What's the feedback from those carcasses when you push them that hard? But there's the availability for whatever your goal is to work with breeders and get you there.
All right, I think we have time for one planned question. And since I'm the moderator and I'm asking, it's going to be about methane because that's what I study. So, Logan, can you talk to us a little bit? And Justin, you can add on here, anybody that studies methane. Actually, Steve and I have a grant that's going to go in. We're going to try to measure methane at his ranch. So anybody can pile on here. But what about methane in grazing systems? And Logan, since you've taught me the most about this, I'm going to come to you first. What are the challenges? What do you think about? Where are the opportunities? Talk to us a little bit about measuring methane, enteric methane from these guys.
Yeah, so I sometimes get distracted when I give talks, so I'm not 100% sure what I say all the time. But to me, like the seminal work was in the 90s, right? And we don't know a lot. And when I see the models that we have, we just have the new USDA greenhouse gas handbook. You look at the equations, and then as I said, I'm not a great animal scientist. I just like to measure stuff. When what I'm measuring is nowhere close to what the models are telling me, it means we have a very long way to go. And also people like Steve might not get a fair shake if the markets come before the science is ready, right? So we really need to focus in on adequately defining our baseline, right? And one thing I often think about is now that I have to teach kids, which is exhausting because I'm not that social of a person, is we know if we a lot of what we do as cattle managers and landscape stewards are trying to improve the nutritional status in the rumen. Right? At the end of the day, we're trying to improve the nutrient balance that's going on. I showed you that that heifer that was a 3.5 body condition score with a fresh calf. We have a ways to go with that girl if we're gonna keep her in an 84-day breeding window, right? Like, we are in trouble with her. If we improve nutritional stats, we should improve emissions. We just don't know by how much, and we don't know in what systems can we see the largest gains. Because cow-calf is 70 to 80% of our footprint, right? If we're going to make an actual difference, that's where it's going to have to come from. And we really need to shift our focus from confinement systems that are complicated but not complex into grazing systems that are complex, which really just means we don't know the laws that are governing it at all times. Right? That's what complexity is. I don't know if that answers your question. Very good.
You did great. Anybody else quickly want to?
I would just add to that, I think that, we've got a lot of good research tools that work in confined scenarios. I think we've got to find ways to leverage that kind of data to tools that we can apply at scale.
I just echo the same thing. It's really simpler in the feedlot system to have a green feed system and the animal's attracted to. It's really difficult to get that animal acclimated when you're in a large pasture. Steve's talking about thousands of acre. We're working on a couple 100-acre pasture. It's hard to get them attracted to it, to get the data off the grazing land. I think the other thing that's unknown is that longitudinal study of how are the animals doing in terms of their methane emissions on grazing lands, and do they rank out the same when they move to the feedlot system? Right, and to come back to what was earlier on the genetic side, which one are we selecting, right? Can we find the animals that are low emitters on rangeland, grassland, as well as in the feed yard? That's a win-win situation for us, right? And I think there's some really rapid advancements that Steve and others could use on his place in a commercial setting.
And I just thought of one quick thing to add on. In the feedlot, individual animals, it's exceedingly easy to do, and we have the facilities. Cow-calf, we can't guarantee what that cow is going to eat of that supplement. We need to move our monitoring beyond the individual animal level into the herd level. That's where we're really going to see a difference, because we can pencil in that they're going to get their 200 milligrams of monensin or whatever. Unless I'm formulating it, then I'll mess it up. Right? But we can pencil it in, but those animals are all going to eat variable levels. Right? So we have great tools, but we need to expand those tools to a herd level when it comes to cow-calf.
Awesome. Well, thank you very much for all of your comments, for the questions we got from the audience, and hopefully you are more confused and also have additional clarity about grazing systems and the beef production life cycle. Thank you, guys.